welcome back to my channel Cat Voyager. This is me Mayanka Chattopadhyay, and today I am back with another problem, or better to say a continuation from the concept we learned the previous day. And let's get started. The question is on your screen. It says that at what value of x will the following expression have minimum value, and the expression is mod of x minus 1 plus mod of 2x minus 1 and dot 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 plus mod of 100x minus 1. So before solving the problem, let's do a quick recap of what we had learned yesterday. And if you remember, we had learned that if we had a function of x given by some x mod of x minus 1 plus mod of x minus a plus mod of x minus b plus mod of x minus c, like that, then the critical points are given by x equal to a, b and c, and if the number of critical points are odd, then we used to have a graph that looks like this or this or like this, or you can say a graph with a pointed bottom for the case when we had odd number of critical points. When we had even number of critical points, then the graph used to look like this or like this and so on. So we had basically a graph with a flat bottom or a line parallel to the x-axis, and from that you could solve the value of x, and also if you would have plugged in the value of x in the function, you could have got the minimum value of the function at that point or within these particular points or within these ranges, right? So that was the key takeaway from yesterday's session, and so let's get started with today's problem. One important thing to note is that in all such functions we had the coefficient of x as 1 in each mod. In each of the mod we have the coefficient of x as 1. That is a thing to note here. I will come to it later why I am emphasizing this. So now you can see the main difference from that particular function to this particular function is that here the coefficient of x are different in each of the modulus. Here we have 1, here it is 2, here it is 3 and so on. It continues up to 100. So now you can think, then what is the big deal here? How many terms we have? 1, 2, 3 till 100. We have 100 terms here, right? This is your first term, this is your second term, this is your third term, and we have up till 100 or 100 mods we have. So you would say, yeah, we have even number of modulus, and according to you we would have a curve with a flat bottom, and within the range of two middlemost values we could have had the minimum value of this function at within that range of x. So you would say, what are the critical points? The critical points are x equal to 1 here, x equal to 1 by 2 here. How did I get 1 by 2? To determine the critical points, we equate this to 0. So you have x equal to half. In this case, what is your critical point? You will equate this to 0 and your x would become 1 by 3, right? So you would say, what are our critical points? Our critical points are x equal to 1, half, 1 by 3, 1 by 4 and so on up to 1 by 100. Now let's look this function from another angle. Let's say we have this function as fx equal to some mod x minus 1 plus mod 2x minus 1 plus mod 3x minus 1 plus dot 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 mod 100x minus 1, right? Now we will write this one as it is. Then we will take 2 common from here. So this will become x minus half within mod. We will take 3 common from here, like this, and at last we would have 100, and this is your x minus 1 by 100, right? Why we have taken the equation, the function in this form? Because if you remember correctly, I said that in the case for the case to apply that particular concept where you just by looking at the graph you know that at what value of x or at which range of x you get the minima values. In that case we used to have the coefficients of x as 1. So I have changed this function in such a way that the coefficient of x are 1 within each of the mods, if you notice correctly, right? This is also 1. Now you can consider this 2 or 3 like this up to 100. These are weights of the modulus. What do I mean by weight? The meaning is the more the weight is given to a modulus, the more it would try to draw the graph towards that particular point. Like I'm saying that suppose for this function your x equal to half has a lesser weight than your x equal to 1/3, this particular modulus, right? So your x minus 1 by 3 modulus will try to draw that particular shape of the graph towards more towards itself, or towards x equal to 1 by 3. And the maximum weight we have in this modulus, that is your 100. So it will contribute to the maximum deformation of the graph. What do I mean by deformation of the graph? Suppose from yesterday's example we take a function something like modulus of x minus 1 plus modulus of x minus 2. We have 2 critical points, x equal to 1 and x equal to 2, and your graph would look like this is 1, this is 2, and like this with a flat bottom. Now if we take another function like this one, modulus of x minus 1 plus modulus of 2x minus 1, what are your critical points? For this modulus the critical points is 1, and for this one the critical point is 1 by 2. And now we will try to rearrange this function, because we want to have a modulus we want to have coefficient of x as 1 within a particular modulus in our function. So what we would do, we would take 2 common from here. The modulus of x minus 1 by 2 we would have, and the coefficient of x is 1, as you can see. So this will become x minus 1 plus x minus 1 by 2 plus x minus 1 by 2. We can treat these two as 2 different moduluses. So now what would happen? What would happen is that as this x minus modulus of x minus 1 by 2 has more weight, or the coefficient is more than that of modulus of x minus 1, the graph will be drawn more towards the x equal to 1 by 2 point, and the deformation will occur on the side of the x equal to 1 point. We will still have 2 different sharp edges in the graph, or 2 different notches, as we discussed yesterday, because we have 2 critical points, right? So the graph will look something like this. If this is your x equal to 1 by 2 and this is your 1, your graph will be like this. This is no more a parallel side to with the x-axis, slightly slanted this side, and as you can see we have 2 sharp edges within the graph. So this happens due to a different weight distribution within the modulus. Now for your ease of understanding, I am taking another function. Suppose this is x, modulus of x minus 1, this is modulus of 2x minus 1 plus modulus of 3x minus 1. As usual, we will try to have coefficient of x as 1 within the modulus. So we will take the 2 common from here. This will become 1 by 2, and we will take 3 common from here. This will become 1 by 3. Now, how many terms we are having? We are having one term from here. We will break this as modulus of x minus 1 by 2 and modulus of x minus 1 by 2, and this, from this we will have 3 terms, like 3 modulus of x minus 1 by 3s, right? So one term from here, or 2 terms from here, and 3 terms from here. We actually total have 6 equivalent terms, but the number of critical points are 3. As you can see, x equal to 1, x equal to 1 by 2, and x equal to 1 by 3, right? So in the graph we will still have 3 different sharp edges at these 3 different points, and as the weight of x minus modulus of x minus 1 by 3 is more, the graph will be drawn more towards the modulus of x minus 1 by 3, or x equal to 1 by 3 point. Now I have plotted this graph in Desmos, and I am going to show you the graph. So here is the graph of that particular problem. As you can see, this is a flat bottom, this is a flat bottom here, and the equivalent points are, this is your 1 by 2, this is your approx 1 by 3 or 0.33 something, and there is another view of the graph. Yes, this one. So here is one sharp edge, here is the second one, this is the third one. This is your x equal to 1 point. If you drop a perpendicular from here, it ends up at x equal to 1, 0. So this is the particular graph of that problem. The concept we learned from yesterday is still the same, because from the problem above we can rewrite that function as mod x minus 1 plus mod x minus half plus mod x minus half plus mod x minus 1 by 3 plus mod x minus 1 by 3 and plus mod x minus 1 by 3. Now if you notice how many terms we have here, we have total of 6 terms. That means the total number of terms is even, and according to what we had learned yesterday, the minimum value occurs in case of a function with even number of moduluses. The minimum value occurs within the range of the 2 middlemost terms. So which 2 are your middlemost terms here? This one and this one. So you can say that your minimum value will occur within the range of x equal to 1 by 2 and x equal to 1 by 3, and that is pretty evident from the graph. We can see in the graph, this is the point that corresponds to your x equal to 1 by 3, and this is the point that corresponds to x equal to 1 by 2. So rightfully within these 2 points we have your minimum value, and that is equal to 1. You can cross check it by plugging in the values. The original function we had was x minus 1 plus 2x minus 1 plus 3x minus 1. Let's put x equal to 1 by 2. So this one becomes 1 by 2, this one becomes 0, and this one becomes 3 by 2 minus 1, or half. This is 0, and from here we will have half, and the value, minimum value of this function is equal to 1. That is also evident from this particular graph. Now let's look at the main problem we had today. The problem was mod x minus 1 plus mod 2x minus 1 plus mod 3x minus 1 plus dot 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 mod 100x minus 1. what we will do is we will take common the coefficients such that the coefficient of x within the modulus becomes 1 for each of the moduluses. So x minus 1 plus this is x minus half, this is x minus 1 by 3 plus 100 is common and this becomes 1 x minus 1 by 100. Now we have to calculate the total number of terms within this particular function. By total number of terms I mean not the terms, not only the moduluses, because the number of modulus we have in this function is 100. As you can see, 1 2 3 4 like this 100 moduluses we have. What will happen, let's look carefully what will happen from this modulus. This is a single modulus. From this particular modulus it will be x minus 1 by 2 plus x minus 1 by 2, that means total you have 2 terms. From this particular modulus we will have similarly 3 terms, right? And it will go on. Total number of terms are 3 and it will keep going on. For the next term, which is modulus of 4x minus 1, we would have 4 terms and each of the term will be modulus of x minus 1 by 4. You can visualize it, I guess. So the total number of terms are in this, total number of equivalent terms, better to say, in this function is 1 plus 2 plus 3 plus 4 dot 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 100. If you have already read AP, then you know this sum is nothing but n into n plus 1 by 2 and your n here is 100. N is the number of terms and the number of terms here are 100. So this sum becomes 100 into 101 by 2. So we have 5050 total equivalent terms, right? Notice that 5050 is an even number. So by that we conclude the minimum value will occur somewhere between two middlemost terms. So if we divide this 50 by 2, you will have this number. So that means your minimum value will occur between this term and this term, right? So let's try to determine what these terms will be. Okay, so let's think that the mth term, let the mth term will be this one. So we will have sum m into m plus 1 by 2 as 2525, or better to say not equal to, almost equal to, nearest to something we are looking for. So this will be your m into m plus 1 equal to 5050. Now by trial and error, let's look at what the value of m can be, right? Let's start with 50. So if m is 50, m plus 1 is 51, and you will have this particular value as this, right? Let's try 60. If m is 60, then this particular value would become 60 into 61, or that becomes this. Still we are far from this number. Let's take 70. If m is 70, then 70 into 71 is your, we are almost there. Now this means that your value of m is 70. This is for sure. That means we had something like this: x minus 1 plus modulus of 2x minus 1 plus modulus of 3x minus 1 and dot dot dot. We had up till 70x minus 1, and the number of terms till this is nothing but your 4970 by 2. This is your this many terms. Total 2485 terms are already here. We are aiming for this number 2550 because we want to, as I have already told, we want to know this particular term, 2525th term. So what is the immediate next term after this modulus? That is your 71x minus 1. That means 71 is taken common and x minus 1 by 71. This means that we have total 71 numbers of modulus of x minus 1 by 71. So how many equivalent terms we will have when we get finished by this particular modulus and we move on to the pretty next term, that is 72x minus 1. So we already have 2485 terms. We add 71 with it, and this is your 2556. We already crossed this one. That means, what does that mean? That means that your minimum value will occur somewhere between these two terms. This modulus of x minus 1 by 71, and the very next term will be x minus 1 by 71 again. Between these two terms, within somewhere you will have the minimum value of your function. Let me repeat that again. Up till 2556 equivalent terms, we had this. We are ending with this particular term, x minus 1 by 71, right? And up till 2485 terms, we were ending with this, your x minus 1 by 70, this terms. So that means the terms in between are all x minus 1 by 71s, mod x minus 1 by 71s, right? That means if your 2556th term is also x minus 1 by 71, then your this 2525th term is modulus of x minus 1 by 71, and this term also is your modulus of x minus 1 by 71. That means your minimum value will actually occur in between these two particular numbers, or that is the same value of x, that is x equal to 1 by 71. That is your actual answer, that the minimum value of that particular function occur at x equal to 1 by 71, this point. Okay, now the thing is, why did I go by starting from smaller functions? Like first I showed you some modulus of x minus 1 plus modulus of 2x minus 1. Then the next function I showed modulus of x minus 1, modulus of 2x minus 1 plus modulus of 3x minus 1. This is a lesson for you, that whenever you encounter a series based problem which have many such terms and you cannot make sense of how to solve that particular series, start by taking smaller series that satisfy the conditions given in the actual larger series. Okay, like in this example we had a larger series that stretches up to modulus of 100x minus 1. If you cannot make sense of it, try to break the series into a smaller series like I did, that was modulus of x minus 1 plus modulus of 2x minus 1 plus modulus of 3x minus 1. I showed you the graph. The conditions of both the smaller series and the actual series are equal because the coefficient of x progresses in an increasing arithmetic progression. So by that, by solving the smaller series, you will get a sense of what the answer for the larger series might be. And yeah, that with that I'm ending this video. X equal to 1 by 71 was your answer, and I hope you found this problem pretty amusing and you actually did learn something from this problem or the related discussion we had previous day. I will be back again tomorrow, hopefully, with another such video on a different topic, maybe geometry or algebra. If you loved the video and actually learned something from it, please do like, share and subscribe. Please share with your friends more and more so that they also can learn from such videos. And at the end of the video you will see a playlist from my channel where I have listed down all the videos I have made so far. Please go back and watch them if you haven't already. Thank you, and I will see you soon. Bye bye.